Okay, thank you very much, Zofia, for the introduction. Good afternoon, everybody. Thank you very much for making it to this presentation. Should be starting now imminently. Yep. Can you see the first slide? Okay, thank you. Okay, so as Zofia explained, I'm going to give you an introduction about the EASI Level 2 products and more generally give a perspective about the hyperspectral atmospheric sounding products because there are future missions on the way. My name is Thomas Auguste. I work at EUMETSAT and I'm coordinating the scientific development and the application studies regarding these so-called Level 2 products, which are the geophysical parameter that we retrieve from the measurements. And so in order to get started, I'll get straight into the subject by showing you an animation of a convective situation that degenerated in a heavy hailstorm in the southwest of France in May 2018. And if you know the area of Bordeaux, you would surely recognize that it's not common to have snow-like cover in May at that year. This was hail, and the hail actually destroyed all the vineyards of Cognac. And so one thing we will try and address today with the EASI Level 2 and the reason for this introduction is to see how we can use this data to observe and monitor instability before the clouds develop, because this is so far the traditional way for forecasters to monitor such situations. So the hyperspectral sounders, which is the family to which EASI belong, are there to help detecting pre-convective situation before the clouds develop. And this will be one main topic of the talk today. So before we go on, and I'd like to ask a little bit of your contribution for me to understand a little bit the audience. Okay. I'd like you to take now the pen. You have a virtual pen each on your computer, and you should be able to put a mark like that, for instance. And I would kindly ask you to place yourself in this scale, whether you're going to hear for the first time about this data, whether you have some experience. Thank you. Lovely audience, very reactive, very colorful, brilliant. Okay, so I think we're done. I'm not counting, but I see plenty of answers. So that gives me a good indication that we have quite good core of people who have had some exposure to these products and even have tried some and are nearly to use that operationally. But we have also participants who are going to hear for the first time. So in this presentation, I'm going to start from the basics to introduce also the concepts of the hyperspectral sounding that we can understand the products. But then to the end, I will show example, an overview of the application study that we're conducting, and maybe we'll speak more directly to the people who have had experience already with it. Okay, we'll move on to the next slide, and I will kindly ask you to annotate again, so we'll stop annotating. Also to complete my understanding, I have introduced myself and I would like you to introduce yourself very quickly. If you could place yourself in these columns to see who I'm talking to today and who, yeah, the discussion is going to be with. Okay, it's very creative and colorful. Okay, thank you very much for that. It's very helpful to me to know how to maybe focus a little bit the speeches. So for the forecasters and the research developers, you will see a number of examples of such application studies, and feel free to ask any questions on the way or later. Okay, I'll stop the annotation for now. I think that gives me a good figure already, and we'll move on. So the outline of the talk will be a brief introduction of the EASI instrument. EASI stands for Infrared Atmospheric Sounding Interferometer. So I will explain briefly the principles, how the instrument measures, and the viewing geometries. Then we will introduce the atmospheric sounding principles with such instruments, and the capabilities of the profiles that we are retrieving. Then I will present the regional service that Sophia mentioned in the beginning, whereby the EASI Level 2 products are available within less than half an hour to the users. And I will explain briefly what these products contain. Then I will introduce the future missions of the hyperspectral sounding family that EUMETSAT is planning, namely the EASI Next Generation and MTG-IRS, which is typically a nowcasting mission. And then finally, I'll give an overview of user application studies that we've been conducting to prepare today and exploit as much as we can EASI L2 already, and prepare tomorrow in view of especially MTG-IRS. That will be a very brief overview because the rest of the week is actually devoted to each of these studies. So let's get started. EASI is an instrument flying on board a satellite called METOP, and the acquisition principle is as follows. It is scanning across a satellite track in groups of 4 pixels, and there are 15 views either side of the nadir. And the swath is about 2,000 kilometers large, and which means by the projection, the pixels are about 12 kilometers at nadir and 40 kilometers on the swath edge. So that gives you an overview of a scanning line, and the different colors highlight each of the 4 detectors. So we often refer to IFOV as a EASI pixel. That's an individual field of view. And again, 12 kilometers at nadir and 40 kilometers at the swath edge. So that's the typical spatial sampling and scale we're dealing with when we talk about temperature and humidity profiles from EASI. Okay, so what is EASI measuring is actually a spectrum, and that is an example of one. And in that spectrum, there is a number of different information from different molecules, but also surface, cloud, and aerosol properties. And the work we are doing with my team is to retrieve this geophysical information out of the spectra, and in particular the temperature and humidity profiles, but many others which are recorded here. The talk of today will focus on the temperature and humidity profiles, and ultimately we managed to deliver such products. This is a relative humidity field, one of the extracted from the regional service, and I will come back to that, and I will explain how we managed to make retrievals in the complete field. EASI is flying on board METOP. METOP is a satellite in orbit, in low Earth orbit, flying at 800 kilometers. And there are actually 3 platforms in this program, and they are all in space and still operational at the moment. They were launched in 2006, 12, and 18 respectively. And with this satellite, we achieve a global coverage twice a day. METOP is also the contribution to the joint polar system with NOAA, whereby the 2 agencies agree to operate sounding missions in complementary orbits. So EUMETSAT covering the so-called morning orbit, and the US the so-called afternoon orbit. So on board METOP, there are a number of instruments, and we will talk today about EASI. That's the main we will focus on, but also about 2 companion instruments, namely AMZU and MHS, which are microwave sonder, which we are exploiting in synergy with EASI, and I will come back later on that. Why is this? Because the atmospheric sounding with infrared instruments are only possible in clear sky or in the portion of the atmosphere that is above the clouds. With EASI, we cannot sound within the clouds or below the clouds, but the microwave sounders have the ability to probe the atmosphere within and below the clouds in most conditions. So the utilization of the 2 is a big advantage, and we will see that again later. So what do these atmospheric sounders measure? They measure, as far as EASI is concerned, 8,461 spectral samples in the infrared, and we will hear about the future missions again later. And we have the microwave instrument, AMSO MHS I mentioned, which are also sampling in altogether 20 channels. On board METOP, there are UV instruments, but they are not relevant to our topic today. So that you probably know, what they are measuring actually is the spectral signatures of the different molecules in the atmosphere, and that results as a cold gas that the atmosphere put between the hot source, the surface, and the satellite, here the instrument, in absorption figures in a continuous spectrum. And so if there was no atmosphere and if the surface had no properties, then what EASI would measure is a boring spectrum here. But in fact, there are many things on the way that result in all these spectral signatures here. And the work is to retrieve the profiles of temperature, humidity, and many others from these measurements. So now I'm going to show a few examples of the EASI spectra to give you a feeling of the information content in it, and I have another 2 or 3 slides just to give these notions, and then we will dig directly in the profiles themselves. So here you have example of EASI spectra at different places on the Earth, and you see that the surface temperature has an effect on the energy that is measured, but also the ozone absorption line, and the temperature profiles are retrieved here in the CO2 region mainly, and the humidity is retrieved from this spectral range. Another example of what we can discriminate with the EASI spectrum is different type of clouds and dust particles. You have in red here clear sky or clean spectra, and in black the corresponding spectrum for the different clouds or dust particles we're here. So we see intuitively that the form of the absorptions can be exploited to determine what we are probing. So now, how do we retrieve profiles from that? What we have to know is that the absorption lines that the molecules create have different intensity and width depending on where they are in the atmosphere. And what the instrument is measuring is actually the convolution of all these emission and absorption through the atmosphere. And by being able to resolve these absorption lines, we can infer the vertical distribution in concentration, but also in temperature of humidity, for instance. And what is critical to that is the spectral resolution of the instrument and the radiometric performances, which I will illustrate now. So what we're seeing here is an extract of a EASI spectrum. Okay, so we see clear, very small detailed absorption figures. And here are broadband channels of the imager MSG Severi, which I think most of you will be familiar with. And what I want to show now is a function called the weighting function that is telling you for each of the channel where the information is coming from and how is it resolved vertically. And here we are seeing that these functions for Severi are really, really broad. So there's not much vertical information that we can retrieve from this instrument. It's mainly total columns usually, or maybe 2 points in the profile. I'm plotting exactly the same concept now for 85 channels of EASI, and you see immediately that we can access to a much more highly resolved vertical information here. But these are only 85 channels. Now I'm showing the same for 850 channels, and actually EASI has 10 times more, but I'm not going to display them because it would be overwhelming. But I hope that gives you a feeling for how the spectral resolution translates into the vertical resolution, and why we are talking about atmospheric profiling now with these hyperspectral instruments family. Okay, and if in addition to that we add the microwaves, we have exactly the same concept, plus the possibility to sound in clouds. Okay, one word of warning. There are vertical structures, small scale, that have no signatures in the EASI observations. It means that the measurements do not contain any information about these small, low level or fine scale inversions or vertical variations. Also, one thing to remember is that the sensitivity and the resolution of these instruments near surface is relatively low. And what I'm showing here as an example is an extract of a temperature profile from ACMWF numerical model, where we see a nice low-level inversion that EASI is having a hard time to depict fully. So we only see an inflection. And that is not due to the retrieval. It's not the deficiency of the retrieval. This is a characteristic of the instrument and of its measurements. So that is something to bear in mind. The retrieved profiles will be smoother than the truth. And so to give you a feeling for the vertical resolution we can expect from EASI, these are the requirements that were set to it to be able to retrieve temperature with 1 Kelvin precision in layers of 1 kilometer, and humidity with 10% relative humidity precision in layers of 2 kilometers. And I will give a dedicated talk tomorrow morning about the actual performances. So really, I'd like to convey the message that yes, we do profiling, but I want also to manage expectations. And Zofia insisted in the introduction about that. This is work in development because really with you, with the users, we are learning how to use these products, knowing their strengths and characteristics and limitations. So here is an illustration of a sound profile in red, where you can see a number of fine vertical scale structures. And the corresponding retrieved profiles from EASI A and B are in the 2 shades of blue. So broadly, we capture the inflections, we capture the main structures, but we are smoother. Okay. So in fact, the hyperspectral sounding, they are a smooth version of the truth, and as I said before, they have a lower sensitivity near surface. That's intrinsic to the measurements, and that's what it is. But still, they are capable of providing useful thermodynamic information, and this is what we are trying to evaluate and to study further with these interactions with the users. Here is an example of a sounding from EASI in the region of Tuzla, Bosnia-Herzegovina, and the sounding was actually made at 8:45 UTC, and you have here the sounding from EASI. So we see clearly there is some cape and potential for convection. And actually a few hours later, indeed, we had convection. So that is just to give you a feeling that despite the smoothness and the limitations, we do find also useful information, and we want to learn with you how best to exploit that. Okay? So now comes the regional service. Where can you access this data? EUMETSAT has set up since November 2017 a regional service called EARS-IASI Level 2, whereby these profiles of temperature and humidity are available within less than half an hour from sensing for all the area covered here with these local receiving stations. And I showed that before. This is a 3D view of relative humidity, which I constructed from an overpass over Italy. So what do these products contain? What are they made of? They are available on EUMETcast in near real time. They are HTF5 files. The format is normally easy to browse, but if you have questions, we have a user help desk. And they result from statistical retrievals, which are fast and accurate, and we will come back to the figures tomorrow morning. They exploit microwave and infrared sounding, which means they are quasi-available all sky. And very importantly, they are forecast-free products. So there is no numerical weather predictions in the retrieval process. So they are totally forecast-free. And here is a humidity 3D structures, which I also reconstructed from an overpass off the coast of Japan. So in these products, you will find temperature profiles in every single pixel, humidity profiles, surface temperature and emissivity, if you're interested in, cloud intensity or cloud signal, and quality indicators. And I will come back tomorrow to explain how you could use these quality indicators for your applications. Okay, so I mentioned there are currently 3 EASI flying in space, and I'm showing here an example of their coverage last November 2019. So EASI A in red, you can see the swath here, flew at 8 UTC, and about 40-50 minutes later came EASI C with quasi at the time overlapping swath, and EASI B 1 hour and 15 minutes later. So with the combination of the three, you should have a pretty nice coverage twice per day. Okay, are there any questions so far before we continue? Okay, just wanted to give an opportunity to breathe and digest the information. Okay, so I see no questions for now, no hand raised. Let me check. No, okay. Okay, so let's move on then. I will present briefly the future sounding missions, because once more, this work we are doing with EASI Level 2 is relatively recent. We're doing it, of course, to exploit to the maximum EASI Level 2, if there are applications possible today, but also in view of future missions. And future sounding missions are the following: on board EPS second generation, so we will have the METOP second generation. We have EASI next generation flying in. So the spatial resolution will be the same. The spectral sampling will be twice better, and I haven't put it here, but the radiometric noise will also be twice better. So we expect better vertical sounding performances. Coverage twice a day, so exactly the same as EASI, just better. And there will be MTG-IRS, MTG standing for METEOSAT third generation. So this will be a geostationary infrared sounder that will have a... So I'm seeing questions now. Can you talk about moisture feature tracked horizontal wind retrievals in the triplet? Okay, yeah, I didn't think of a slide for that, but I can. Okay, there is a question for those who haven't read it. Can you talk about moisture feature tracked horizontal wind retrievals using the 3 EASI triplet overpasses, and what that might mean for MTG-IRS wind retrieval? So indeed, with the humidity structures, temperature structures, and even ozone structures that we are retrieving from EASI, and given that there are 3 flying over the same area within 1.5 hours, we can see atmospheric structures moving, and there has been studies at EUMETSAT to derive wind profiles from these thermodynamic thrusters. And I can't give a date for the trial dissemination of the prototype products, but certainly around 2021, the first prototype products derived from EASI triplet should be made available to the users. And obviously, this is a precursor to MTG-IRS. I will come back to that in a slide or two. But MTG-IRS will observe Europe every 30 minutes. So we will have a much better coverage over Europe than we have from EASI, and therefore a much better ability to monitor atmospheric motion vectors. And that's certainly an objective of these wind profiles to in view of MTG-IRS. Okay. So here is a little animation to show you the spectral resolution that we have from EASI, EASI-NG and MTG-IRS. And you see that EASI-NG is much more resolved than the other two, so we expect a better vertical resolution. And MTG-IRS is slightly coarser than EASI, but still very close to it. Okay, yeah, and that's just to illustrate again that with a better spectral resolution, with EASI-NG we will have a better vertical resolution. This is the weighting functions for temperature, so it peaks lower and and the width is thinner as well. Okay, MTG-IRS again will be flying on board the geostationary satellite MTG, and will scan the Earth in 4 local area coverage, so-called LAC, and which are depicted here in 4 different colors. And each LAC will be acquired within 15 minutes, and the spatial resolution at nadir will be 4 kilometers. And Europe will be observed every 30 minutes. So that's a major innovation. because we will have operational spectral imagery at high spectral, spatial, and temporal resolution. So clearly, we will have access to a dynamic 3D view of the atmospheres. And coming back to Philip's question, yes, this is clearly an objective of that mission, to be able to derive 3D wind profiles. Yep. Okay, this animation shows you the repeat sequence. We jump from LAC 4, Europe, to the other LAC. But LAC 4 is revisited every other LAC, therefore every half an hour. Here also to give you a feeling, and that's important to keep in mind when we work with IASI, because we need to project that also in view of MTG-IRS. I'm showing here a simulation of IRS observation, and this is brightness temperature in a channel, in the window channel. And I'm overlaying on top of that the IASI footprints. So you will recognize the 12 kilometers at nadir and the 40 kilometers at Swarth Edge. Okay, and you can see the little tiles of IRS. So that gives you a feeling for the actual spatial resolution and sampling that IRS will allow compared to IASI. So here an example of a central part of a scan line, and here a Swarth Edge. And IASI within the day will only provide 2 measurements, actually 6 with the 3 platforms, but they are really next to each other, whereas IRS will be measuring every half an hour along the day. So that's the big innovation, and should be extremely useful to sample also the atmosphere at the most pre-convective time of the day. IASI usually is flying a bit too early, but still in some situations convection starts early in the day, and has proven interesting also already in that respect. Okay, so just to complete the introduction on MTG, you are used to monitoring weather development as soon as the cloud has formed with Imager, and the follow-up of CDRI on MTG will be FCI. When lightning are triggered, then the lightning imager will be able to see that. And with IRS, we expect to evaluate the thermodynamic state before the clouds form, and hence to gain precision and lead time in the assessment of potential severe weather. Okay, so I'm done with the introduction of all the instruments, the principles of the atmospheric sounding with these instruments. We have talked about the potential and the limitation, but really where we are now after about 2 years of engaging with the users and studies is to learn still what we can do with these products, and to consolidate the requirements in view of IRS. Because we want to use these satellite sounder temperature and humidity profiles for regional weather forecasts, but there is no operational heritage yet, unlike we have for imagers, for instance. We are building that, and I think everybody is still in the learning phase of what we can do with it, and feeding back to us, the product developer, to maybe adjust the presentation. Maybe in addition to a profile, this is a total column or partial columns of humidity that are useful, some instability parameters, etc. So really the questions in this dialogue with the users, and so with you hopefully in the next weeks, months, is what can be done with IASI already today? What can we learn to evolve the current polar service, and the EARS-IASI Level 2 is an example, and to consolidate the requirements and prepare for MTG-IRS. So what will come next is a quick overview of these studies we are conducting as part of this dialogue with the users. And so in this event week, you will hear about quality performance assessment. This will be me again tomorrow morning. Some centers are already ingesting this data in their weather workstations to try and learn and study. You will hear about applications in windstorms by Christian Herold Wednesday morning, about instability monitoring by Zofia and Yana Champa on Wednesday afternoon and Tuesday morning, how we try to reach out the users and explain to a wider audience what they are, to raise awareness about these products, and that something Peter Gronemeyer from the European Civil Storm Lab will present on Tuesday afternoon tomorrow. User training, I guess what we're doing today is part of that. And we're also conducting, is a bit new and exotic because the paradigm in NWP is the assimilation of radiances, but we're also trying to assimilate level 2 products. And Kirsti Salonen from ECMWF will give you an overview of a study that is finished with them and a new one that is starting on Thursday morning. And to help, we also rely on contribution from Scientific Advisory Group for EASI, IASI-NG on the left side, and the IRS Mission Advisory Group on the right side. So, okay, tracking the instability with EASI Level 2 products, I'm going to show qualitative examples just to illustrate the work, and more details will be provided by the speakers in the rest of the week. So this is probably, as far as I remember, the first case that we studied and this was with Ralph Peterson from the University of Wisconsin. And this was following flooding in Central Europe in June 2013 that were not necessarily forecasted completely accurately. And these are two illustrations of the consequences of that. So what we are seeing here is the animation of Severi, the famous sandwich images that will show the convection initiation. And to the right here, you have the theta E difference, which is an indicator of the instability that is computed from the EASI observations at the time of the overpass now and projected over time by just simple advection of the air masses. And what we realized with Ralph is that a few hours after the overpass and by advecting these air masses, we were able to place correctly the main instabilities later that day. So that's where we thought, okay, maybe there's something interesting, and we should scratch more systematically this. And so as a result, as I mentioned, EUMETSAT set up the EARS-IASI Level 2 products service, and the DWD, for instance, is ingesting routinely this data in the NINU monitoring facility. And it is also work ongoing at the Hungarian Met Services. We will hear about that later this week from Zofia. And so in particular at DWD, they looked into the utilization of these products in support to forecasting European cyclones. And you will hear more from the colleague later. Another example I wanted to show and share here is a case we looked at, strong storm in Dordogne, again, southwest of France in July 18. And you can see a few illustrations of what it was. Houses were completely damaged and became irrecoverable because of the hailstorm that thrashed the roofs. And then the rain flooded the inside, and there was nothing to recuperate. And what was interesting is that day we looked at with the ESSL colleagues at this is an extract from their facility actually. At what were the models saying for that day. So this is the Cape here from ECMWF forecast at 9 UTC. And this is here the Severi tile at 950 UTC. So the same area where the troubles occurred later is circled in red. So there wasn't much of instability here in the forecast, maybe a little bit more in the GFS, but it's not massive. And interestingly, the structures can be different from one model to the next. And this is the ICON EU forecast, also not massive instabilities there. Interestingly though, in the EASI products, we could see trace of instability, which is represented here. And looking at the details of the profiles, we realized that we retrieved warmer temperature than the forecast, and that resulted in potential instability. So that's again a qualitative, and what really we are after is a more systematic use, also to learn about the limitations and the cases where it's not working so well. But interestingly here, there were signs of instabilities in that area where later that day we actually had a number of convective cells that merged together and resulted in these consequences here. Okay. Another example, and we will hear more details later this week, studies conducted at Hungarian Met Services. We're seeing here a situation with a cold front progressing and triggering convection. And here is the maximum buoyancy computed from IASI, and the front is represented here. So we clearly see that there is an area with high instability where it was actually unstable. More details were presented in this presentation to the user conference, possible usage of IASI Level 2 profiles in nowcasting in Tallinn 2018. But one notion I'd like to come back to is the fact that the hyperspectral sounders have less sensitivity near surface, and we can't hide it. This is a fact, and the resolution is also coarser in the first 2 kilometers. And this is illustrated here with what we call the averaging kernels, which is a measure of the sensitivity to at a given altitude for temperature. So the temperature retrieved in this layer is actually, okay, sorry, I'll start with this one, it's easier. So the temperature retrieved at, say, here we are at 200 hectopascal, is actually a combination of information coming from this Gaussian here. So the resolution is actually broad, and these averaging kernels are conveying this information. Where is the sensitivity for a given layer, and how resolved it is in the vertical. And so we have the same notion here for humidity, and what we're seeing is that there is little sensitivity near the surface, and the resolution is relatively coarse, so 2 kilometers layer basically. And we know that for some instability parameters that require an accurate representation of the temperature and humidity near surface, this could be a potential issue. So one thing we are exploring with the Hungarian Met services is to blend satellite sounding, whereby we could retrieve some CAPE here, with ground-based observations to replace the first layer temperature and humidity. And immediately, this is qualitative. You will hear more specifically later this week. We see that we can get a more realistic CAPE figure. So this is work ongoing to figure out the practical aspects of that, of blending the two informations. Yeah, that's the same illustration of the same principle. Here, a CAPE retrieved from IASI. If we blend with the surface observation, we get a slightly higher CAPE. There was a CAPE already, but it gets larger if we blend with the surface ops. That is important to the forecasters. And the same if we look at the NCWF forecast for that day, we have some CAPE, and if we blend it with the surface ops, we have also a larger CAPE. In that case, IASI resulted in a higher CAPE because we had a higher lapse rate than the forecast. And that in our many interactions with the user, and I'm showing here an example of another fora where we engaged with the users, that was with the European Severe Storm Lab. The feedback we are getting is that to the extent that it is accurate and with the limitations and the characteristics we know, an independent information from the forecast to complement the forecast and the work of the forecasters was desired. So we are working along these lines. I'm approaching the end, but I hope you're still with me. So you will hear later this week about case studies that the ESSL experts have conducted themselves. You will hear also a summary of the feedback they have collected from European users. They were training in these test beds in June, July 2018 on the potential use of these products. And now I will finish just by showing a few examples of assimilation of the IASI Level 2 products in NWP model. Once again, the operational paradigm in NWP is clear. This is the assimilation of radiances, but we wanted to perform these experiments to feedback also on our products and maybe as a scientific exploration. So there were two studies, one conducted at Météo France, and you will not have a presentation this week about that. I will show one slide, and one at ECMWF. The setup, I will not enter the details, but the setup were relatively simple. So there were a number of simplistic assumptions to make this first experiment. But nevertheless, we had encouraging and interesting results, and I will show you some glimpses of that. So what I'm showing here is the result of an assimilation of level 1, so the radiances, which is the operational baseline, and of level 2, so with the retrieved profiles. And these, the forecast resulting from the assimilation of the level 1 of IASI and level 2 of IASI has been compared to a number of reference data. And in that case, I'm showing comparison of relative humidity to ground radar. I'm showing the standard deviation of these differences. So in this plot, you see the red is the baseline experiment without any IASI, without any AMSU and microwave, so not even the radiances and not the level 2. So this is the baseline for comparison. And with the level 2, we see that we improve on the baseline in most layers, and this was in winter, but the same results also got observed in different seasons. So this is one of the very positive and encouraging results we had with this experiment. There were situations or metrics where the assimilation of the level 2 were not improving that much, and you could, if you're interested, look at the full reports on that. But I just wanted to illustrate this positive result because it is relatively new actually. And there haven't been much assimilation of level 2 products that resulted in such results. Okay, and at ECMWF, same principle, only we realized that the assimilation of humidity and temperature was problematic. So in the first study, we ended up assimilating only the humidity. And these graphs are showing you the impact of assimilating the level 2 products on the forecast on temperature on the left side and humidity on the right side. And both forecasts are compared to radio zones. And if the graph is moving to the left, we have an improvement. And in blue, you have the assimilation of radiances, which is the operational baseline. And so in gray, you have the assimilation of level 2. So by assimilating IASI level 2 humidity, we don't degrade the temperature information in the model, but we don't improve it either at this stage. But by assimilating the IASI level 1 radiances in blue, we improve the forecast in humidity, but we also improve by assimilating the level 2 products, the humidity. We improve the humidity forecast to relatively the same amount as the radiances. So that was the good information. And this was only clear sky with the best retrievals. And we moved a bit further and tried to ingest also cloudy retrievals. So here you're seeing the performance of the forecast compared to SON. So there is an improvement if we go to the left and degradation if we go to the right for humidity and for temperature. So as I said, temperature, we don't improve, we don't degrade, we are neutral. And humidity, we improve. But that's clear sky. And now gradually we will add cloudier and cloudier retrievals, and we see that until a moderate cloud coverage, we still have a positive impact, which was interesting. Okay, voilà. So you will hear more later about that with Kirti's presentation, and there is a study to continue and go on and assimilate the level 2 products in a mathematically more complete manner. So I'm coming to the end of the presentation, and I have seen Adam's question, so I'll come back to that. Just to recap, we are aiming at the regional applications with these products. There is currently already sounding of temperature and humidity from IASI and AMSU and MHS, so from METUP, that is available in nearly all sky. And available to you within less than half an hour. So that's the EARS-IASI level 2 service. So what we want to do is to learn in view of IRS, to monitor pre-convective situations and more. You will hear also example of Shapiro-Kaiser cyclone, for instance, whether that could be useful there as well. And really what we want to do by engaging with the users is study the hows, so how these products could be used and get the feedback to consolidate the requirements in view of IRS. Bearing in mind that we are dealing with smooth profiles and taking feedback from direct use in weather workstations, assimilation experiments, and exploring further the blending of satellite and surface ops. So to Adam's question, which is this blending technique with surface ops sounds attractive. Is there yet a report or scientific paper on this? So yes, there were actually the idea I first came across in the States. So colleagues from University of Wisconsin tried that, and they have 2 papers, and I gave the references in this presentation. so you can retrieve that. And we also started looking into that with the Hungarian Met services, so Zofia, Maria, and their forecaster colleagues. And there is a study report from the EUMETSAT study, which can be made available as well, and that touches on that. But that was just the beginning, so we're going to, I understand the work is continuing in the Hungarian Met services, and we will hear more later this week about that. But certainly this is an avenue we want to explore further and to support. Okay, and so to contribute to the user preparation, we have activities and retransmissions in the convection working group. That's a good forum to exchange on your respective results. We have the user training, so that is an example, for instance. We can make near real-time tests. At the moment, we have only the EARS-IASI Level 2 service, but it could be evolved to something closer to IRS later. There are user programs, namely called MTG-UP and EPSSG-UP, that my colleagues of user service divisions are organizing. And there will be a series of webinars mid of October. And so if you're interested, we can get the information to you. And we are conducting a number of case studies with users and fostering international cooperation within Europe, but also in the States, for instance, to keep learning about that. So that brings me to the end of my presentation. I really appreciate your listening. It's a pity I can't see you. I like the interaction. But really, please try out the EARS-IASI Level 2 and get ready for MTG-IRS. So that's it for today. Thank you very much again for your listening. I'm really keen on taking any questions you may have.